Welcome to The Explainer. We have this funny tendency today to think of ourselves as sitting at the absolute peak of human achievement. We've got smartphones, space travel, AI. But what if I told you that in some absolutely crucial ways, modern science is actually just now catching up to the lost engineering marvels of our ancient ancestors? Today, we're unpacking exactly how societies from thousands of years ago were pioneering technologies that we're literally still trying to figure out today.
I mean, think about this. Did ancient blacksmiths forge nanotechnology? It sounds like pure science fiction, doesn't it? We usually picture nanotechnology as something born in sterile, multi-billion-dollar modern laboratories, definitely not in the dusty, soot-covered forges of the ancient Middle East. Keep this question in the back of your mind as we go, because the answer is going to completely change how you view history.
Okay, let's dive into this. For a really long time, the secrets behind these ancient marvels were completely lost to history. It's only recently that materials scientists and engineers have started acting like, historical forensic detectives. Armed with high-resolution electron microscopes and advanced chemical analysis, they're finally peeling back the layers of these ancient masterworks to understand the sheer brilliance of the past.
Section 1. The Advanced Ancient World.
To set the stage, across the globe, these ancient civilizations were innovating at an incredible pace. Over in Mesopotamia, they were utilizing the wheel and engineering complex screw pumps for water management. Over in the Indus Valley Civilization, in places like Mohenjo-Daro, they actually had advanced, closed plumbing and sanitation systems that wouldn't be seen again in many parts of the world for millennia. And in ancient China, they were already casting iron and building early seismological detectors to monitor earthquakes. These societies were master engineers long before the modern era even kicked off.
Section 2. Hadrian's Secret Concrete Toilet.
Now, what's really interesting here is the totally jarring juxtaposition between our modern materials and theirs. Concrete is the single most consumed building material in the world today. Yet our modern concrete usually begins to crumble and degrade within about 100 years. On the flip side, Roman concrete, the stuff used to build massive structures like the Colosseum and those sprawling aqueducts, is still standing strong after more than 2,000 years. So how is it possible that our state-of-the-art concrete is so utterly outmatched by a recipe from antiquity?
Believe it or not, the secret was hiding in Emperor Hadrian's 1,900-year-old toilet. Yeah, I know, it sounds like a complete joke, but this is actually brilliant archaeological strategy. A research team out of UC Berkeley, led by engineer Paulo Montero, realized they needed perfectly preserved samples of Roman concrete. So they turned to the latrines at Villa Adriana, Emperor Hadrian's summer residence, built between 117 and 138 AD. Because these toilets hadn't been altered or renovated by modern human hands, they offered a completely pristine, original look at this miraculous ancient material.
So what's actually going on inside that concrete? Well, through high-res microscopes and X-ray scans, the researchers unlocked the brilliant chemistry at play. First, the Romans mixed volcanic ash with lime and water. This triggers something called a pozzolanic reaction, which creates these incredible binding properties. But here is the absolute genius of it. The researchers discovered that the material essentially has self-healing capabilities. Over the centuries, calcium compounds in the concrete react with atmospheric carbon dioxide. This process, known as carbonation, produces a mineral called calcite. Whenever tiny cracks form in the aging concrete, this calcite literally grows into the microscopic pores and cracks, binding the concrete right back together. The Roman buildings weren't just sitting there, they were actively healing themselves for 2 millennia.
Section 3. Damascus steel and nanotubes.
Let's move to something that builds on this perfectly. Used for roughly 2 millennia, from 300 BCE all the way up to 1700 CE, Damascus steel blades possess this almost supernatural, legendary status. They were known for their beautiful, fluid, wavy surface patterns, their unbelievable flexibility, and their ability to hold a razor-sharp edge. Capturing the mystique of these blades, the author Lamont Fouquet wrote in an 1845 romance, "They resound, they glitter." For centuries, European smiths tried and completely failed to recreate the specific properties of these weapons. The forging technique was totally lost to history. The mystery really deepens when we look at the chemistry. Damascus weapons were forged from a highly specific type of steel from India known as wood steel. Now, wood steel has an unusually high carbon content, somewhere between 1.5 to 2%. In modern metallurgy, we know that if you push carbon content that high, the metal usually becomes incredibly brittle. It should basically shatter upon impact. Yet, Damascus blades could reportedly bend double without breaking. So what on earth was giving this high carbon metal its legendary strength?
Well, the answer absolutely stunned the scientific community. Back in 2006, researchers at Dresden University in Germany took a sample of a Damascus saber and put it under a high-resolution transmission electron microscope. They discovered that ancient blacksmiths had inadvertently forged state-of-the-art nanotechnology. Hiding inside the steel were remnants of iron carbide wires, which normally would be brittle, but they were encapsulated and protected by carbon nanotubes. The blacksmiths, entirely through their specific forging techniques, were actually manipulating matter on an atomic level.
To really wrap our heads around this, we have to understand graphene, which is a single atom-thick layer of carbon arranged in a honeycomb lattice. The researchers in our sources beautifully describe it as atomic-scale chicken wire. Now, imagine taking that microscopic sheet of atomic chicken wire and rolling it up into an ultra-thin tube. That is a carbon nanotube. It's quite literally the bleeding edge of modern material science, and yet there it was, hiding inside swords forged hundreds of years ago.
So why does that matter? Well, 50. That's the magic number here. Multi-walled carbon nanotubes possess a tensile strength roughly 50 times greater than normal steel, all while remaining incredibly lightweight and flexible. By unknowingly growing these carbon nanotubes within the steel matrix, those ancient swordsmiths were giving their blades that mythical blend of razor-sharp hardness and unbreakable flexibility.
Section 4. Ancient Tech, Modern Solutions. So the crucial point is, what does this all mean for us today? Let's look back at that Roman concrete. Modern concrete production is incredibly harsh on our environment. It releases just a massive amount of carbon dioxide into the atmosphere. But by studying that 1900-year-old Roman toilet, modern experts are hoping to implement those ancient calcite secrets right into our current manufacturing. If we can trigger that exact same self-healing carbonation process, we can produce incredibly durable concrete with a radically lower environmental impact. We can literally build sustainable modern infrastructure using the wisdom of Emperor Hadrian's architects.
And what about that Damascus steel? The carbon nanotubes found in those ancient swords are exactly what today's scientists are trying to manufacture for real sci-fi level innovations. We're talking about weaving macroscopic nets of these tubes to create next-generation bulletproof vests. We're talking about using their unique electrical properties for the electronic materials of the future. And honestly, most mind-blowing of all, they're the primary candidate for building space elevator cables, a tether reaching 36,000 kilometers into geosynchronous orbit. It's a concept that requires a material lighter and stronger than anything we currently mass produce. Yet it was hiding right there inside a medieval sword.
Which brings us to a really thrilling question to wrap things up. What other world-saving technologies are buried right under our feet, just waiting to be rediscovered? I mean, we found self-healing infrastructure in an ancient latrine and nanotechnology in antique swords. As modern science continues to look backward, who knows what lost genius will turn out to be the key to our future? Thank you so much for joining me on this explainer today. Keep questioning, keep learning, and I'll see you next time.